Hi, welcome to another edition of Sunday School. We'll get started in about 2 minutes here. It's 2:58 of mine. Can I get a comment or a chat or something like that just to make sure I'm live and this is all working? In the meanwhile, while I wait for one, I will continue getting set up. Got a new keyboard. Somebody, I think it was Brandon, had last time said that my previous keyboard was loud, so got a new one here today. Hopefully it's quieter and not as annoying. For keyboard nerds, I like blue keys. Let me show you. I like these ones. This is my normal blues. If you pull the keycaps off, here I'll pull it off. I'll show you. I got my key puller here. You got these blues in here. These are my favorite because you can really feel when they click, but pretty annoying for people that are listening in. Let's see. Instead, I got this new one. Oh, it's connected though, so it's a little hard to show off. It's got reds in here. A little hard to see. I got bright LEDs. But reds are Cherry MX reds are quieter, so hopefully they're better for you folks. All right. What I want you guys to do is let me pull up my screen here. In the repository, which is this thing on GitHub, these things are called repositories. I'm gonna start putting all the code for all of our lectures in here. Oh, let me turn this gain down a little bit. All right, that should be a little better. I'm gonna put all the code. Oops. Sorry, I'm messing with my settings right now. Putting all the code for all the SQL classes. They're gonna be right here in the 101, 102, and as we progress, they're gonna go on. So what I want you all to do is I want you to grab this setup script right here, and you can just copy and paste it. Just have it handy. And so I'll give you a second to do that. And what I want you to do, I'll do it first, then I'll give you a minute to do it yourself, is I want you to open up your SQLite browser. So you can't see it on this screen, but on the other screen I typed in SQLite browser. It should you should have this installed from the last class, and it'll bring up this little window right here. If you're new to this stream, you can just go over to this link right here, SQLite browser, click on it, and you'll see the web page. Just hit download and grab the one that works for your computer. Whether you're in Windows or Mac or on Linux like me. So I'll assume you have that. And then what I want you to do is I want you to make sure that you have the SQLite databases. Let me pull that up as well. So on my computer, they look like this. Northwind large. Northwind, we'll get to modified in a second, but Northwind, we want the Northwind large specifically. And where to grab that? If you go back to the original page, we want to go to this repository, somebody else put together. We're going to want to download this file and then unzip it to get the large. If you're coming in from, I don't know, if you're going to watch this live stream later, maybe on another day, we go through all this in the SQL 101, so you can watch that to get set up and get started. Rebecca asked, what should we be copying? Nothing yet. Let me talk you through it. Do you have this Northwind large on your computer, Rebecca? Put this on. Ooh, it's on normal latency, so this might be a little longer. Code-wise. All right, so quick note, I accidentally selected normal latency for streaming lag today, so it'll be a little bit longer, but I'll use the chat more often. Cool. We'll be copying this. So here's what I want you to do, and I'll type it in the chat. So we get it. Copy Northwind large and to a new file and name it something else. So like I said in the chat, I want you to copy this. I want you to paste it. And I'm going to rename this modified. You don't have to rename it, but I just want it to be a different database. What we're doing here, we're gonna modify your database a little bit for today's class. I don't want you to modify your original file, your original database. I just want you to make a copy, and then I want you to I basically want you to make a copy because we're going to modify that one instead. Once you've created a copy, I want you to open the modified one. So File, Open, and then in my case, I'm going to go to Repos. I'm going to go to Intro to SQLite, and then I'm going to go to Modified. I'm going to hit Open, and you should see these tables pop up. So open up your modified Northwind. Open up your newly copied great, and the stream is caught up. So you should see these. What we're going to do now is we're going to click on Execute SQL, and just to make sure things work, I want you to just type in select star from customer and then hit play. And as a reminder, this is just where we write our SQL queries and we execute them. And so we can see all of our customers. The specific thing I want you to do today is I want you to copy this. I want you to paste it in here. And I want you to hit run. And what you should see is at the bottom is query executed successfully, delete from, order, and some stuff like that. What you should also see is now we have two more tables, table 1 and table 2. And since it seems like I've got a couple people's attention, I will wait a minute to see if confirmation of whether this worked for people or didn't. This one is going to be critical for today. Greg says he's missing the command for table 1 and table 2 creation. It should be in SQL 102. And then if we click on setup, you'll see a create table 1, create table 2. Accidentally closed the browser. Let me paste this right into the chat. There we go. Great. I'll assume Greg will have it once he executes it. So I'll give him maybe 15 more seconds. While I was doing that, I'll explain what's going on. For today's lecture, to make it maybe land and make more sense, we wanted to create, or I wanted to create some custom tables to make the points a little bit more clear. So what's happening, and this is not part of the lecture, so don't feel like you have to memorize this yet or understand this yet, but essentially what this is doing is this is code that is either creating a new table, so creating a table 1 and creating a table 2, and this is also code that is modifying our order table here, in its essence deleting rows. You won't need this for the 100 series, not really that important to understand, but it is valid SQL code that DBAs and other people more advanced in SQL would use. We're just gonna take it for what it is and just accept that it's gonna make some not necessary but desired changes in our code, and we'll continue on from there. No, give me one sec. All right, back. So, what are we going to cover today? Now that we're all set up, we're going to cover 3 or 4 things in today's class. We're going to cover ordering results. We're going to cover subquery syntax. We're going to cover joins, by far the most crucial element of this class, and actually a very fundamental topic for dealing with data in general. And we'll do aliasing, which is a pretty easy one. Well, this will take like a minute. But really, the focus of this class today is joins. Joins essentially are what they sound like. It means joining 2 things together, and in data that usually means joining 2 pieces of information together. A lot of times when you're working with data in the real world, almost every time you're working with data in the real world, you'll never have all of your information in one place. Sometimes it'll be in one Excel sheet and a file. Sometimes it'll be in one database or another database. Sometimes it'll be in a file and in a database. And a crucial thing and a skill is to put these 2 pieces of information together in a seamless way. So even past SQL, if you're going to move on to, let's say, Python and pandas, joins are a fundamental concept in pandas. If you're going to move on to like the big data technologies like Spark or even Hadoop or any of those sorts of things, joins are still relevant. So it's a concept that's started in relational databases and structured query languages, but now is spread all over the data world. All right. With that, we covered joins a little bit last time. Let's start with the basics and go back from there. So we created these new tables. To see what's in them, we can write a query. So we're going to do select star from, let me make this right, from table 1, and I'm going to hit run. And what we get here is all the results from table 1. We get 1 through 3. Does anything about the syntax look weird, or anyone want refreshers or have questions before we continue on? Mm-hmm. All right, I'll take that as no questions. So this is our basic this is our basic select. We're gonna see what we created in table 2. I'm gonna hit play, and now we see table 2. So we've got 2, 3, 4, and then B, C, D. What we're gonna do is we're gonna put these on 2 separate tabs. And so here's table 1, 1, 2, 3. Here's table 2, 2, 3, 4. And since this is a small table and I'm constructed this way, you can tell there's an interesting nuance here, that there is I call these both letter, but let's see, that this is this table has the numbers 1, 2, and 3. This table has the numbers 2, 3, and 4. So one concept in relational databases and almost all data stores that are good, what they have is what's called a unique identifier. Sometimes this is called an ID, sometimes this is called a key, but what it essentially means is this is a number or something that uniquely represents this row of information. In this case, it's almost always on the left. I'll just point that out. It's almost always the first column, not always, but almost always that first column all the way on the left. And it's most of the time a number, but not always a number. And if we look at, let's take one of our other tables, and I'll click on Browse Data this time. You'll see that here's an ID for, in this case, orders. And it starts with 10,000, but what each of these numbers is a unique number that represents a particular order in our larger database. If we do the same thing with customers, in this case the ID is not a number but a string, but you can kind of get the sense that none of these repeat. This is a unique key, and it uniquely identifies each company name. So it's important for two reasons. For a human, actually for both a human and a computer, it's important because it uniquely identifies a row. And for a computer, it's particularly important because if it's been designed right, it's in a way that makes it easy for the computer to represent that single row. So like, let's take a person's name. There could be two people named Greg, and there could be two people named Rebecca. I'll wager to guess that both of you have met people with your same name. So a name is not necessarily always unique. But when you as a person go into a database, let's say Facebook or Google or anything like that, you get a unique ID represented to you, so it becomes clear who you are in the entire computational sort of space, or in that data store in particular. In the same way, let's take this Around the Horn company is now uniquely identified with this ID called AUROT, or AUROT. If we look at the schema a little bit, and you click on this, usually they have these little stars in SQLite. This is what tends to indicate that these things are what's called primary keys in that table, the unique identifiers. It just so happens that they're named ID in this database, but they do not have to be named ID. Now, why that's important is when we decide to do joins, when we decide to put two pieces of information together, what we need to do is we need to tell the computer we want to take table 1, and I'll explain what left join means in a second, and we want to join it to table 2 on table 1 ID equals table 2 dot key. Whoops. Table 2 dot table 2 key. And when I run this, you're going to notice something. We will talk about what it means in a second, what the results mean in a second, but let's talk about the syntax. When I'm saying, actually, let me specify this fully. There we go. What I'm saying is that in table 1, this ID, I want it is a, it's not equivalent. How do I say it? This ID correlates to this key in table 2. And ID and key, I'm going to say them interchangeably. They generally mean the same thing in a database concept, but it basically means a number 2 here correlates to a number 2 in table 2. And so what's happening is that, let's copy this. Let's open that up. Let me run this. In table 1, I have all this information. In table 2, I have all this information. I want to take the corresponding information from table 2 and sort of tack it on to table 1 where it matches. So in this case, I have 2 and B. In this case, I have 2 and B. And I want to grab 2 and B and tack it on to 2 and B over here. I know I named this a little more confusing with since letter and letter are the same, but let's ignore that just for a second. because I want to tack these two pieces of information together, I have to tell the database how to do that. And the way I tell it is I say, take table 1, and on the left, join table 2, and where the rows on table 1 equal, where table 1 to table ID equal table 2 to table 2 key, take that row and tack it on right here. In fact, to make this a little bit more clear, let's actually do this. Let's go back to our keys right here, and let's change this to B, table 2, C, table 2, and D, table 2. And then let's hit run. And I will wait 20 seconds for this stream to catch up and to get a confirmation that you all have were able to get this to work successfully. You can verify by going to table 2, hit play, and now you'll see these new values like this. Greg, the right window to copy to is execute SQL. This tab all the way on the left. Execute SQL tab. Sorry, on the right. Great. So one person got it. Good thing this live stream is recorded, so you can copy it. Let's take this query as we had before. Let's run it again. And this makes it a little bit more obvious. This on the left looks like table 1, right? You can see that here. And this on the right looks like some of table 2, not all of table 2. And so here are the values for table 2, and here are the values we get back. Makes it a little bit easier to tell the difference. So what is happening here? This query is saying from table 1, which is on the left, go to table 2, and for the row that equals table 1 dot table ID, so in this case, the table 1 dot table ID in the 2, go to table 2 and grab the row that is in that key column that is also equal to table 2. That is also equal to 2, the number, and grab all those values as well. And so in table 2, we have a key here that's the number 2, and we have, in this case, now a word, but the letter called table 2, and sort of put these two things together. To make this a little bit more explicit, what we can do, Greg, I only have 2 tabs open on my command option. Greg, I'll have to get a screenshot from you later to understand what's going on. I guess for now, just watch my screen and try and understand through the lecture. So previously we had select star. We can make this a little bit more explicit by saying table 1 dot table 1 ID, and then we can put a column here and say table 1 dot letter, and then we can say table 2 dot table 2 table 2 key, and then we'll do table 2 the table 2 letter. To Rebecca's question, so it's the key ID that matches, not the letters. Yes, it is whatever is in the on clause for what it matches. In this case, because in here we said on table 1 ID, which is this, and table 2 key, this is what it looks for a match. it was not matching on the letters. If I had wanted on the match on the letters, we could do this. But we don't want it to match on the letters. And I'll explain why. So just to show you, there's nothing wrong with doing this. This will still work. But you will get a bunch of nulls on this side. I'll explain what null is in a second here. So nothing wrong with this query, but it's certainly, for this exercise, is not what we want. And later on, it'll make more sense why we don't want it when we have actual sort of examples. So let's go back to our join on the particular IDs. In this case, we're telling it to join on these numbers, and we're grabbing all 4 of these columns. So now we're doing 2 sorts of things. Let's say we don't want this table to key. We can actually just comment it out and hit run. And now we just get back the ID from table 1, the letter column from table 1, and the letter column from table 2. In fact, we could even just mix and match it, hit play, and now the columns sort of just switch position. So I'll just put it back like this. So now there's a couple things going on in this query. We're telling it we want to grab everything from table 1. We're telling it we want to grab everything from table 2, where there is a matching where there's a corresponding row from table 1 that matches the key from table 2, and we're telling it we want to just grab a couple of these columns. So this is the basics of joins. Now for the trickiest part is what specifically left it means. I'll show you what the 2 kinds of joins are in SQLite, and then I'll talk through them. So there's 2 kinds of joins. There's what's called a left join, and there's what's called an inner join. What a left join means is, and what it's saying, is it says grab everything from the left table, and it makes a little bit more sense when we write it like this. Grab everything from the left table and join to the right table where there is a matching row in table 2 where these 2 columns have the same value. The other kind of join, and let me point this out like this, is this thing called an inner join. When I run this, inner doesn't mean a lot of sense intuitively, but what it means in practice is grab only the rows where there is both a value in table 1 and a value in table 2 that match. And the way to see this is to just look at the rows. In this case, in table 1, we have the values 1, 2, and 3 in the ID column. In table 2, we have the values 2, 3, and 4. So just thinking about it in memory, 2 and 3 are in table 2, and 2 and 3 are in table 1. And so the 1 is not in table 2, and 4 is not in table 1. I know there's a lot of numbers here. Why that matters is when we do an inner join, we only get back the 2 numbers or the 2 rows that match. If I go back to a left join and I run this, you'll get back everything from table 1, but not everything from table 2. You can see that we're missing a value from table 2. An interesting thing as well is, let's say we switch the orders of these. I want to put table 1 on top, table 2 on top, and table 1 sort of at the bottom. Actually, let me do the left-right syntax again, like this. And let's add in up here, let's add in table 2 dot key. When I run this, you'll see the opposite effect. You'll see that now we get back everything from table 2. Let's actually move this once more to make these 2 tables come together. All right, you'll see we get back everything from table 2. We get back all the values from table 2, but not all the values from table 1. because now we're saying grab everything from table 2 on the left and join table 1 where there's matching records on table 2. Join types. And so let me show you something. If you just Google join types, you actually end up getting a nice picture that looks like this. Where did it go? And this is probably the easiest way for me to, this was the easiest way for me to understand the join types. This picture in particular. Because the left join right here is grabbing everything from table A and only the matching records from table B. An inner join is only grabbing the matching records from both, from the equivalence operator. There are these other joins. I would say for now, you don't have to worry about them. There's two reasons why. One is that they're not in SQLite, kind of on purpose. They're not supported. So if you try full outer join or right join, you'll get an error. The other is you almost all don't need them. In most databases, frankly, the left join and the inner join are like 95% of the joins. Like you really just end up using these two the majority of the time. You almost rarely end up using the rest of them. My advice is learn these two, the difference really well. Once you understand the difference between these two, understanding what's going on with these other ones will become much, much simpler. So going back to our particular join, the ones we care about, left join means return everything from the left, table 1, 2. Find me all the records on table 1 where the ID for table 1 is equal to the key for table 2. This query is a little bit of a mouthful to write, so we can do a thing called table aliasing. In this case, we say table 2 as T2. We can say table 1 as T1. And now we can simplify our query by just copying in these everywhere. So instead of typing out table 2 every time, I can just do this, T1, T1, T2, T2. I can hit run, and everything still works. So this is called aliasing. It's very handy and it's nice because it means we don't have to repeat everything all over the place. And I guess just to show you, you don't have to put aliasing in if the column names are unique like this. Everything will still work. You can see that it's still functioning when I hit play. But it's a really good idea too, because it makes it easier to understand where these columns are coming from. It'll make your life when you're debugging much, much easier if you explicitly list it out versus if you don't. And it also catches errors. So for example, let's say I change the order like this and I hit run. You'll actually get an error that says no such column, T2 table1.80. So you'll get some nice feedback from the computer, because if you remember, table 2 doesn't have anything called table1.id. So in this case, when I'm saying t2.table1id, which means grab the table1 ID from from table, grab the table1 ID column from table 2, it will give you this error, does not exist. That's very handy because you can then go back and just fix this, hit run, and you'll get back your successful 3 rows returned message. And so this is the basics of joins. I will pause here for maybe 15-20 seconds to ensure that we're all good on joins, and then I will cover order by and subquery. So let me give you a second. All right. I'll take that as no questions. So let's keep this in mind for joins. One other nice thing we can do is we can just order things in SQL. So let's say, do you have to identify the alias in the from area? Yes, you do. That's how you know what the tables are aliased. It didn't seem to work for me. I can play with it later. Shoot, I will. Yeah, I'll have to figure out a way to see people's queries. All right, lost Greg a long time ago when I opened the second execute tab SQL. Sorry, Greg. You just have to watch me on the screen. I don't know why you don't have the execute tab. Oh, you can hit this play button, and this little button here gives you another window. Hopefully, that's what you were looking for. All right. So let me copy this and put this in the chat. Let's see how this pastes. And you guys can copy and paste it into your section. So one other handy thing with SQL is you can order things. So if I type in order by table 1 ID and I hit run, you'll get back the same thing. Doesn't look like much is going on, but that's because it's ordering it just the way it already is. If I type in order by table 1 ID descending, and I hit play, oh, descending does not work. Ascending, and there we go. I don't know why that happened. If you type in DESC, which is shorthand for descending, what it'll do is it'll take the results and it'll order them in this case descending. And if we want to do ascending, we just type in play. And we get back everything in ascending order. Greg says all kinds of errors from typing everything into one execute SQL tab. Yeah, if you have an error anywhere in your SQL, let's say not real SQL, and you do this, what's going to happen is it'll fail everything out. So I would advise opening up multiple tabs with this little button here. That way all your code is separated and you're not just running into errors from all the stuff at the top. It's good to keep this clean, otherwise you'll keep running into issues. As far as ordering goes, I hope this one is the most intuitive. You just hit order ascending, it comes up in ascending wise. Otherwise you hit order descending, and your order goes down descending wise. So that's order by. Hopefully not too much to it. The last one, which is going to be the trickiest, is subquery syntax. So let's say I want everything from table 1. So let's say select star. Let's copy it from here. Table 1 ID T1 letter from table 1, and I hit play. Oh, I get this error, no such column T1.table ID. So Rebecca, earlier when you were having an issue, I hit table 1 as T1, I hit run, and now everything works. And when I take this out, I get my error below. So T1, everything works. I can say I can have a where filter. So remember where we had where letter equals A, and I would just get back the letters that were equal to A, or I could say table 1 dash ID is equal to 2, and I just get back the row that's equal to 2. There's also this handy in operator where I can say table 1 ID in 2, 3, and I get back the rows 2 and 3. So this is kind of nice when you want to grab multiple columns. But a tricky thing you can do is you can do this thing called a subquery, where you say select table 1 ID where table 1 ID in select table 2 dash key from table 2. and I hit run, and I also go back 2, 3. What's happening here is this query is giving me back every table 2 key from table 2. So in this case, it's going to give me back the values. Let's see if I still have it here. 2, 3, and 4, because it's grabbing everything from table 2 key. And then what I can use this as a filter for my higher level query, where I'm just saying, get me everything from table, give me these columns from table 1, where the table 1 ID is in all the values that are returned from this query. So now this is called a subquery because this is a sub or one level lower than the main level query. You could even do one where you say not in, and I run this, and now I get back all the rows from table 1 that are not in this column from table 2. Or sorry, I get all the rows from table 1 where the table 1 ID is not in the column table 2 key from table 2. So this is an easy way to tell whether all the columns from one table are in another table. And where this is important is when we go back to the concept of joins, this will give you a sense whether an inner join will give you back all of the rows or not. Because if there are keys that are present in table 2 that are not present in table 1's ID, then those are the rows that'll get filtered out. So if I go back to my join, where I say left join table 2 as T2 on T2, or sorry, T1 that table 1 ID equals T2 dot table 2 dot key, and let me comment these two out, and I hit run. Oh, and let me also add in T2 dot letter. And let's do T2 dot table 2 key. Now I'm getting back everything from table 1 like before, and I'm missing the rows in table 2 that I don't have. This where filter helps me figure out that only these 2 rows would have showed up. Again, let's just take this one query. I'll comment these 2 out. I'll add these 2 back in. Oh, no such column. Okay, now that I'm only calling from table 1, there's no such column as T2 and T2. So let me copy these out, hit run. And I just get back the one row that is not in table 2. If I comment these back out, remember this, 1A, and I add these back in, and let's comment these back out, and I hit play. Now the row on table 1, it comes back 1A, but there's no corresponding row in table 2. This is where these nulls are. Null in SQL parlance means missing or not available. I do get back the 2 rows on table 2 that correspond. So subqueries are just nice when you're exploring databases and you're trying to figure out which keys are represented where. You can use subqueries to see are all the IDs in one table available in the other table, or all the IDs in both tables sort of consistent, and if you do a left join and an inner join, you'll keep everything. Because remember, in this case, if I do an inner join, I'm going to lose a row, but if I do a left join, I'm going to keep a row, and I'll just get some empty values back. In practice, the left join is you don't use one or the other. Sometimes you just want everything back from the left table, and you just want missing values where missing values exist. An example is in like the exercise, you might want all the employees at a company, and you might want to join to all the orders, and then you want to know every order in which employee placed it, but you don't want to miss out on the rows where employees have not placed an order. So like, let's say you want a list of all employees and all the orders they've had. If you just hired on somebody today, you want them in that list. You want to know that they're in that employee list, but they're going to have a null on this side for orders because they haven't actually placed any orders yet. Think about it if you just sign up for, like, let's say you just created an account in Best Buy. If you want, let's say that you haven't bought anything at Best Buy yet, but some analyst at Best Buy wants to know all the customers of Best Buy. In one case, they might just want to know everyone with an account and the orders they've placed. If I haven't placed an order yet and I do an inner join, what will happen is that I'll implicitly be filtered out because there's no order associated with my account and I'm removed from the list. In this case, a left join might be appropriate because you want to get a list of all customers. And even if they haven't placed anything yet, you just want to know that even if they haven't placed an order yet, you just want to know that they are available within an account. My advice is, if none of this makes sense, just take this one query as it's written and just do this left and this inner and just really get a sense why this one row drops out and why this row comes back. If you get this, you'll get the fundamental difference between the two. The very last join I want to show you, and I'm clicking on this little button here to create a tab, is what's called a cross join. So let's copy this for expediency's sake. So I'm going to copy this query. I'm going to bring it over here. And what I'm going to say is I'm going to say cross join. And with a cross join, you won't need to specify an on condition, because a cross join does something a little bit special. It takes every row from the table 1 and it adds on every row from table 2. So in this case, we have 9 rows. If you take 3 rows on one table and you take 3 rows in another table and you join every row with every row, 3 times 3 is 9. If I had 3 rows in the left table and 4 rows on the other table, 3 times 4 would be 12, because what it's doing is it's taking 1A and it's pairing it with 2B, and then it's taking 1A and it's pairing it with 3C, and it's taking 1A and it's pairing it with 4D, and then it's taking 2B and it's pairing it with 2B, and then it's taking 2B and it's pairing it with 3C, and you sort of get the point. This type of join doesn't get used too often in queries that I've run. I've done in the last decade or so. It's just, I've used it every now and then in special circumstances. I won't go into it here because, again, it's so rarely used, but I just want you to see that this exists, and this is what it does. It does what's called the Cartesian product between 2 matrices. And so with that, I'm going to write this query once more I'm going to write one query from scratch just to show you what it looks like. So what we're going to be doing, this will be very similar to last time. I want to know, actually let's do this together. I want to know every employee and the orders that they have placed. So in this table, I'm going to take a look at the schema. So one question I didn't answer yet was, how do you know which IDs correspond to which IDs? Frankly, it's not always obvious. It really relies on either a schema map. So let's go back to our picture from Northwind. So at a good company, you're going to have what's called a schema map. You'll have one of these things that tell you that this product ID goes to this product ID, or this supplier ID is this supplier ID. Like, hopefully someone at your company has named these things sanely and correctly, and you can correlate across the two and sort of make sense of it. And hopefully you have a resource for someone to ask. Unfortunately, not every company or every company, either a vendor or your company, is going to have this map, in which case you're just going to have to make some really good educated guesses and sort of figure it out. But the best case scenario is you have a map that tells you which ones map with each other. In this case, I'm going to make a good guess. So you can see that we're already running the issues. Products, let's use products. Product is called ID. In this diagram, it's called product ID. We're already having a difference of naming. This is pretty typical for a real world case. You don't always have a nice map, but I can sort of make a guess that that product ID here matches with ID here. This table is named product. I'm going to guess this is the product ID. This thing is called product ID, and I'm going to assume these two things match. I will say that prior to this class, because this is a new database to me, I verified and it seemed to make sense. At work, I asked my coworkers a whole bunch, and they tell me, or I just use the subquery and try and ensure everything sort of just fits in, makes sense. I check with reality a lot. So what we want to do, let's grab all the orders and let's get their corresponding ID. So let's do this real quick. Let's do select star from order detail. I'm gonna hit run. And so we end up with an ID, and we end up with an order ID, and end up with a product ID. This is great. I know there's orders for a whole bunch of stuff, but I don't actually know what the orders are for. Like I really want a report that has the actual order names in them. So let me grab, let's actually do this. Let's do order ID as OD, and I'm just summarizing this table a little bit. I'm gonna say left join, and the reason I'm doing left join, I'm choosing this because I want to be sure I'm getting every order and none get filtered out. By left joining, I'm saying get me everything from order detail and add on the information from product. And I'm going to say as P where, on OD dot product ID equals P dot ID. And I don't want to get, if I do select star, what's going to happen is I'm going to get back all the columns from both tables. So I get back everything. Whoops. Like that. I just want to get back the product ID, and let's do od.product ID. I just want to get back p.product name. I just want to get back, and I just want to get back p.units on order. How do I know where these came from? It's because I can go back to the schema and I can read where these are coming from. So units on order, I can see that product ID comes from here. So I know this is p dot ID, p dot product name, p dot unit price. I know this is od dot product ID, od dot quantity, whatever the case might be. So let's actually put quantity in here as well. od, oops, down. Quantity. I hit run. Awesome. Now I get back. I have this nice little report. Actually, it's a little weird that product name is over here in the middle. So let me make this a little easier by putting product name up here on the top. Let's format this like I would an actual report. I hit run. Sweet. That puts product name over here on the left. And then, cool. Something I want to mention, and I don't think I mentioned explicitly, when you do joins, the order does matter. So the left and the right are actually relative. So if this is left, this is right. So make sure you put these in the correct order or your query might be different. This on here doesn't matter. You can move this around to here like that, and everything will be exactly the same. Nothing will change. So order matters for left joins. Order does not matter for inner joins. In this case, left and inner do the same thing, but if you're using left joins, just be careful. Don't worry about this, and good to go. Now let's say I want to order this like in something that's sort of sane. So I can say order product name ascending. I hit run. Oh, product name is order. So already ordered by p.product name. Whoops. Hit run. Product name syntax error. Okay, here we go. Oh. You can see that now it is ordering by product name. So everything's in alphabetical order, which is nice. Great. All these rows look the same though, so let's go back and let's add in the order ID. Let's say the ID order detail. And what else do we have in the order detail page? Yeah, we got order ID. So let's just go with that. Let's hit run. Okay, awesome. Now I can see these are all different orders that I have in here. Perfect. But let's actually say I don't care about the naming. My boss wants to know which product are we getting the most orders, which order has the biggest for the biggest amount. So let's do order by quantity. Let's say p.quantity descending. And what this is going to do, no column p.quantity. Okay, whoops. Oh, great. So this has helped me. It's not p.quantity, it's od.quantity. Great thing I read this error message right here. I hit run. All right, sweet. Now I know that this chartreuse or whatever it is the most popular, has the biggest order quantity. I will admit, in this table, I don't understand what units on order mean. I don't know this database very well, so I can't tell you what this means. In real life, I would go to the shipping clerk or like the salesperson to be like, what is the difference between quantity and units on order? It's a fake example from a made-up database, so don't know what it means in real life. In real life, I would go ask somebody. Cool. One other thing I want to show you is you can actually order by 2 columns by just putting a comma in. Let's type in a product name ascending, and I'll hit play. And now this is ordering by 2 things. I'm ordering primarily by the quantity in descending order. So these 2 things have the biggest quantity. And then a secondary sort is ordering by the product name in alphabetically ascending order. So because product name is a string, it does an alphabetical sort. So you can see chartreuse is the top, Wimmers, whatever, is at the bottom. And then if I go to my next quantities of 120, I'm ordering J, M, P, and whatever, keep going up. It's a little bit interesting because P, E is before this pate, because it's got the little accent symbol on top of it. Ordering with accents is really hard. This is not the class for it, but Unicode ordering and whatnot is a whole other live session. But you can kind of tell that it's putting these things in alphabetical order. J goes before M. The P's are a little bit weird, but P goes before R, then S, then S. So it makes sense as a human. And so that's essentially the basics of joins and everything like that. I will leave it open now. I have an exercise. It's a little challenging, but I'll leave it here. You can ask questions for the next 5 minutes, and if anyone wants the exercise, let me know, and I will post this exercise and let you guys give a run at it. So we'll pause here for a second and take questions or comments and requests to do the sort of take-home portion if you'd like. All right, I think the stream is caught up with this portion. So I'll say this. There is, in the repository, if you like, there is this README, and it's got these exercises in here. And I will give you a chance to, you can try these on your own. Later on this week, I will post the solution to SQL so you guys can see what the solution will be. But now I want to point this out. There's a trick here. Oh, this is a little messed up formatting. Let me fix this super quick. All right. There's a subtlety with the join. So I would run this one, see how many rows you get back. Run this one, see how many rows you get back. There should be there's a slight sort of trick in there for you to get a sense between left and inner joins. And with that, that's all I have for join, subqueries, and aliasing. Everything covered, all 4 topics today. If you have any questions, just I guess leave a comment on this what is it going to be, this YouTube video, and I will hopefully get around to answering it. Happy Sunday, and I hope everyone is doing well. I'll talk to you later.